Hello, uDev! Once again, please. Hello, uDev! Okay, that's right. Nice to see you all here on our fifth meeting on the series uDev Tech Talks. My name is Vadim. I'm the host of this evening. And as you know, I hope, our very special guest for today will be Michael Feathers. But before we start, I want to introduce to you our schedule and chess puzzles. So first of all, everybody who came here to Kharkiv Palace, you already got your chess puzzles in the souvenir packages, in the black souvenir packages. So we challenge you to solve them. When you're done with them, go and meet our chess experts. They are waiting for you in the hall. And if your solutions turn out to be correct, you will get a souvenir from uDev. As usual, we will follow our standard schedule. So first part of the lecture will be 45 minutes long. Then we will have the coffee break when you can chat with each other, and if you're lucky enough, you can ask some questions to Michael. When coffee break ends, coffee break lasts 30 minutes long. Right after coffee break ends, Michael will start the second part of his lecture. Second part of lecture will be 45 minutes long too. And right after Michael finishes lecture, we will get to my favorite part of tech series. It's a question and answer session, where when you will get a unique chance to ask your questions to the Michael. But remember, guys, all your questions must be in English. And now, the moment you've all been waiting for. Give it up for Michael Feathers! Okay. Good luck.
Good evening. Let me get set up here. Okay. So tonight we're going to talk about refactoring. Okay, how many people do refactoring now? Yay, everybody, of course, right? So refactoring is one of those terms that's been around for a while. It's a practice that's been around for ages. And the funny thing about that is that after something's been around for a long time, we don't think about it all that much. We just kind of do it. And there's always a lot more to learn, right? One of the things I think is utterly fascinating is that the first book in this area, Refactoring by Martin Fowler, it's written in like 1999, and it's a great book. How many people have Refactoring, the book? Only a couple of people, wow. What's amazing to me about that book is that it's lasted forever. There's still many things within that book that are very applicable today. All the examples are in Java, but it doesn't really seem to matter. Most of the refactorings that he discusses and describes in that book are things that you can still do today, and that's very valuable. The thing that I think is kind of missing, though, the thing that's really kind of funny about this, is that refactoring itself was a practice that was basically seen as an individual discipline, something that developers do by themselves, right, which makes sense. But the thing is that we know now that there's so much more that you can do when you work together as a team in order to go and deal with the various different issues that occur in a code base and make things more maintainable. So in order to go and get us all on the same page, let's go and discuss what refactoring is. This is Martin Fowler's definition of refactoring, right? You've seen this before, heard this before? It's kind of good if you have, right? And it's a rather technical definition. It essentially says that you're taking small steps to change the structure of a program without changing its behavior. And this is very different from the way that people use the term refactoring quite often, what they do is they'll say things like, I'm going to refactor in a feature. Have you ever heard anything like that? Okay, I'm going to refactor in a feature. And that kind of muddles the entire idea of what refactoring is. Refactoring is about basically making some changes to sort of make things more maintainable, but preserving the existing behavior entirely. And without having that distinction, you can get yourself in an awful lot of trouble. So this practice has been around for ages, as I mentioned, but the thing that's really kind of funny is that still we're in odd situations. Okay, we end up having things like this. Somebody know what that is? This is a cabin, a house in the woods, covered by vines, right? Is it kind of like your code base? Yeah. So the theory was that once everybody understands refactoring practice, we apply it in the work that we do, and when we apply it, things start to get better and better over time in our code base. But I still visit many teams and see chaos. I see craziness inside the code base. And after years of doing this and helping teams get themselves out of this, helping them get tests in place in order to enable their refactoring and do things like this, we still have this sort of thing. And this forces you to reflect a bit about why this happens at all, right? I think a very fascinating thing is that there are certain things, there's systemic forces involved in software development that we don't appreciate all that much. Somebody ever heard of behavioral economics before at all? Okay, it's a field of economics that's really less about money than more about human behavior, understanding why people are motivated to do particular things. And one of the things that's very interesting about this field is that they run experiments, they make hypotheses and stuff like this, and try to develop economic arguments for things that people do in everyday life that, again, have nothing to do with money. Now, the funny thing about this is with code, we have built-in incentives and disincentives as well against what we do. So here's an interesting question. Is it easier to add code to an existing method than it is to create a new method in your code base? Yeah, and that's funny. Some people will go and say, oh, yes, it's easier because they're good developers and they just kind of know that this is the proper way of going and doing things. But in general, there's less work to go and add code into an existing method than to create an entirely new method. For, the main thing to think about with this is that quite often, if you're creating a new method, you have to come up with a new name, right? And quite often, we don't even want to think about new names. We'd rather just drop the code in place to do things like this. And in much the same way, is it easier to add a method to an existing class or create a new class, right? There's almost some built-in extra effort to create new methods and create new classes. So we really shouldn't be surprised by what we see in our code, right? What we see in our code typically is some very large methods and very large classes because they just grow that way. And if you think again to that picture we showed earlier where you have like the vines growing all over the house and stuff like that, there is this very organic feel to code bases. They tend to be like biology. They tend to grow over time. So we have this kind of thing happening, and it's really something that we need to pay attention to and understand what those forces are. Now, refactoring allows us to go and move away from that, but we have to also appreciate the forces and figure out what we can do to basically motivate the process of refactoring. So it's very typical that over time, code bases are going to grow in complexity. This is just the path of a particular file in a code base, the number of lines in that particular file over time. So you can see a trend here, right? Number of lines in that file has increased, maybe decreased because somebody deleted some code or moved it to another file. But overall, you have this trajectory to go and increase more and more and more. Now, the thing I see with this, and the thing it took me quite a while to discover in software development and teams I've visited all over the place, is that I think some of this is really a side effect of agile software development. Now, the thing is, everybody kind of loves Scrum and agile software development, and I was there in the beginning of this, and I think it's a very powerful set of techniques. But there's a problem, though, with this, and it comes down to the legacy of agile software development, where it came from. So anybody know where this came from, agile software development? If you dig back into the history, you discover that it came from two places. There were essentially two teams in the world that basically did very similar things. The first team that did extreme programming, if you've heard of this methodology, okay, it came up with, the people involved in that came up with test-driven development. They pushed the idea of refactoring. Many different things came from that. And also the people that were doing Scrum. And in both cases, what you had was this. You had an organization where you have business people, And the business people wanted features. They wanted the software to do new things. So they kept saying, we need this, we need this, we need this. And they would complain because the developers weren't really delivering the features. Now, the thing is, the developers would say, yes, we could deliver these features, but you have to stop changing your mind. You keep changing your mind all the time and asking for different things. So we work on something and then have to destroy it and work again and have to destroy it. And what both of these teams did in different areas of, it was actually in the US, they settled on the same type of thing. They said, look, let's have a strong separation between business and development. And let's go ahead and organize things by responsibilities. You can almost see this as the application of software engineering principles to process. So what we did is this. We said the business is responsible for the features. They go to the development organization. And the developers give estimates back to the business. And with those estimates, you decide what the new features are going to be. And you keep on going and going and going with this. Now, the thing about this, though, is that it kind of perpetuated a bit of a problem. And it did solve many things, but it ended up having this particular side effect. Somebody ever heard of this at all? Law of leaky abstractions? Okay. So this guy named Joel Spolsky, I'm wondering if you can actually read that very well there. I'll just explain what he's talking about. He was saying that for any system, any software system, any non-trivial abstraction leaks. And what he means by this is that, to give an example, suppose you have a piece of software, you have a network between two pieces of the software. You can't really abstract away the network because the failure cases, when you have a network, are non-trivial. So there's always going to be some way in which the software is going to be different because you are using the network. You can't just make a function call and pretend that you're not going across the network. Different errors can occur. So he said that this is true of just about any major abstraction you introduce in software, that there's always a case where you have to look behind the abstraction, where you can't completely abstract away something. And the thing about that is that we have that with agile processes in a way. What we're trying to do here is abstract away features, abstract away the development problem using features and estimates. But the thing is, what's missing from that picture? The main thing that's missing from that picture is the quality of the code, right? So if our discussion is mainly about features and estimates, and this is true every place I go, then we're not having the conversation about, did we make these changes well? How is our readiness for change in this area of the code base? And because we don't have that conversation, we end up introducing more and more technical debt, more craziness in the code base. So I see that as a bit of a problem, and I think that that's something that we can kind of start to tackle in the industry a bit better. So I have this different definition of technical debt. Everybody's heard of technical debt, right? Yeah? Technical debt? You've heard of this. Yay, right, okay. So the thing is, there is this definition of technical debt where it's basically things that you do voluntarily in order to go and meet schedule quickly, but you should go back and fix them later, right? And I was looking around to go and say, maybe there's a different way of defining technical debt that helps us as we're doing these things. So the different definition is this. It's the amount of effort it takes to refactor your code to make it easy to add the next feature non-invasively. Now that's kind of a very abstract definition, but we'll walk through an example. With this definition, though, it forces conversation about the things that make your code easy to change. So as an example, let's assume that we have this code here. Okay, we have this little method called add event. It accepts an event. We mark the event as added. And then what we do is we go ahead and we pass it into an events list, and we send mail about the event and display the event, right? So we're doing a lot of work in this add event method. Suppose now that I wanted to add a new feature, okay, to this. Every time we add an event, I want to go and call the event auditor and give it the event also. What's the easiest way of adding that feature? Probably putting that code in line there, right? It's the easiest way to do that. If we look back at the definition that I'm supplying here, technical debt is the amount of effort it takes to refactor your code to make it easy to add the next feature non-invasively. Let's take a look at a non-invasive change of this. It would be ideal if we didn't have to change that method at all to go and add in this feature. Let me show you how we can do this. If the method looked like this, we wouldn't have to go and add in that feature that in this particular method. So notice here, we mark the event as added, we add it to the list. Next we go and we call a list of event processors and tell each one to run itself on the event. What is an event processor? Well, essentially it's just like a list of lambdas, and those lambdas do the work that we had up in here, right? There's a lambda that will be doing a send mail, there's a lambda that does the display, and there's also going to be one that does the auditing. So we would have to refactor this code in order to go and make it look like this. But once we did that refactoring, we wouldn't have to change this code. What we would do is we would add a new lambda to that list, and none of this code has to change, right? That's what I mean by non-invasive. Okay, we basically are able to add the feature in without modifying the existing code once we've refactored it in that direction. Is this a better design than what we had before? Yeah, okay, and it's good to hear somebody in the front row said, yeah, it's a better design, and I agree with you. And the reason why is it's basically true on a couple of different grounds. One of them is this. I didn't tell you what the name of this class is, right? It's actually a scheduling class, is what it is. But why does a scheduler have to care about sending mail? Why does a scheduler have to care about displaying events? And why should it have to care about auditing events? Those are separate responsibilities that really have nothing to do with scheduling. And the fact that it does have to care about these things is a big coupling issue. And that's really something that we should avoid, right? So it's excess responsibility in this class in order to go and do these things. So we're able to do this work. We're able to go and set it up so that we can make the change we want to go and make, but non-invasively. And as you were seeing, it probably involves a bit of effort to do this. We have to modify the code a bit, get that list in place, be able to run through it, change the callers to go and pass those lambdas to set things up and configure things properly. But the nice thing is that once we've done this, this particular area of code doesn't have to change again for any similar change, right? The reasons we have to change this method have become reduced because now we have this generality here that allows us to go and plug in the things we're going to go over. Does this sound like any design principle anybody's ever heard of? It's kind of like the intention behind a design principle called the open-closed principle. And this is one that was first articulated by a guy named Bertrand Meyer back in the 1990s. And he was really talking about inheritance in object-oriented languages. But the same thing tends to be true for just about any aspect of code change. What he was saying is that your design is better to the degree that you don't have to change code very much to add a new feature into it. If you're able to subclass a class and just plug it in, everything is a bit better. And this tends to be true in a code base. If you have a design which is configured right, you can just create new classes and plug them in, or create new lambdas and plug them in. But it's kind of hard to get there because you can very easily over-engineer things, right, if you do a bit too much of that. But think about this definition now, though. With this definition, you start to have a conversation on your team about these issues. And whenever you start thinking about how much it costs to go and basically add a feature in, or how much technical debt you have, you ask yourself, gee, here's a change I want to make. How much effort is it to do this refactoring? The refactoring that would make things easier. And that conversation will lead you towards producing solutions which are kind of like what I was describing earlier, things which are a little bit more parameterizable, okay? So it kind of pushes the conversation in a good way. Do you have much conversation on your teams about this? This thing of how easy is it to change something? Yeah, and it's interesting. Some teams do, some teams don't. But this is a primary aspect of maintainability for the code bases. This and having good tests in place in order to enable the refactoring that allows you to do this work. So this definition of technical debt is pretty valuable for us. What I want to do now in the remainder of this first session is talk about a series of team practices that you can use in order to go and start dealing with refactoring in a more holistic manner. when we see things this way, when we see things like the cost of change is something that we should be optimizing, we can start to arrive at some other practices. One of them is this thing I call design decision cards. And what I mean by this is if you have some particular design decision that you make, a major design decision, periodically re-estimate how long it would take to undo that decision in your code base. And this is valuable even if you never do that work, for instance. To give you a simple example, which is a rather pervasive one, let's say that you're working on something and you target, say, Linux, for instance, and you want to move it to, say, Windows someday, but you know that right now it's on Linux and it will probably always remain on Linux. Okay? If you choose not to build some kind of an abstraction layer for what you're doing, then as you estimate the cost of moving to Windows, it's going to increase and increase and increase and increase and increase. And maybe that's okay, but knowing that basically goes and lets you reevaluate that decision and see whether building an abstraction layer would have been a good idea. Okay? This can also apply to smaller things that you're working on. Say that you have built into a particular part of your design the idea that there can only be one particular product in a particular state. Okay? And you sort of think, well, maybe someday we could have 3 products or 4 products. We could generalize these things. But you don't want to generalize until you actually have that need. But you can still go ahead and periodically re-estimate and ask yourself, if we had to do this, how much time would it take for us to go and undo this decision? A lot of this is the kind of technical debt that creeps up on you when you're working in a large code base over time. We like to keep things as easy to change as possible, right? But there are many different dimensions for change in a code base. So doing this with particular ones can basically raise your awareness of the things that, that may require more work to change later. And sometimes when people do this, what they do is they arrive at the idea that, you know, we thought it was kind of hard to generalize in this particular direction, but we should probably do it now because the costs are increasing, and it's probably a better bet for us to do that generalization now. Next practice is related. It's something I call feature trend cards. And this is really more of a way of going and evaluating how bad of an area of code happens to be, or how bad it's actually getting over time. This is particularly good for communicating with people outside the team. What you do is you find some hypothetical feature, okay, or set of features that would impact a very difficult area of your code base. And it's actually good that these features are things that don't come up within the next month or year, for instance. But you basically go ahead and periodically re-estimate them, and you're able to go and look at the trend and basically see, yes, you know, this area of code is pretty bad. As it gets worse, the costs of going and adding this hypothetical feature are increasing. So these are almost like probes in estimation in order to go and understand when code is getting worse and be able to document that to be able to show people that that's an aspect of neglected maintenance in the code base, neglected refactoring. So this is really more like making the case to the people that you work with that more refactoring is needed in an area of the code base, and also raising your awareness as a team that these are considerations. Next thing is something that I really wish I'd emphasized more earlier in my legacy code work with people. Something I call scratch refactoring, and it's an extremely powerful practice. Often when we're doing refactoring, what we do is we basically do a lot of work to go and get tests in place, right? We get the tests all in place in order to go and demonstrate to ourselves that we are preserving behavior as we basically do our work, right? With scratch refactoring, what we could do is we basically do a lot of refactoring without any tests at all. Okay? Does that sound great? No tests. Yay, we can do lots of refactoring. And immediately this sounds really, really dangerous. But the trick to this is that you're never going to check that code back into the repository. And then you might be looking and saying, well, what's the point of that? Why would you actually do all this refactoring and never check the code into the repository? And the main thing is to learn, right? One thing that happens very often is I visit teams where people are terrified of their code bases. They're really scared of particular areas of the code base. They're scared because they're looking at things which are so hard to understand that they just, you know, any change seems very hazardous. And more than that, if they feel like they want to start refactoring, they don't even know what direction to go and take things in, because they see the code and they kind of, it's almost like there's a dragon in your code, right? And so you don't know where the dragon is, and you're scared to knock on the cave because the dragon can come out, right? But scratch refactoring is all about gaining the knowledge about, whether there's actually something really scary in the code or not, and also understanding what direction you might choose to go and take the code into, right? So there's a lot around this particular practice that is going to be hard to go and talk about in the amount of time that we have here. But one key aspect of this is, if you're going to do this with, say, a large set of classes or functions, don't use an IDE, okay? Just use a plain text editor. Now, this may sound counterintuitive. Why would you use just a plain text editor? Because when you're doing this kind of scratch refactoring work, what you're typically doing is you're taking big things and breaking them down into pieces. And often the IDEs that go in syntax color and actually like compile your code, if you're working in a statically typed language, will distract you because they'll give you too much feedback, and then you start doing everything it takes to make your code compile. And those are actually distractions. So when I do this, I'll basically take some area of code and I'll chop out a function, put it into another place, try to count up the things that are coming into it and coming out of it, pass those as parameters, and often the thing that I extract out, I deliberately make sure it does not compile or run. I just do that in order to keep myself from getting too involved in making things pretty or making things, nicer, because the idea is understanding. And often when I extract out pieces, I use long natural language names. I'll smack several words together and create names that would never make sense in normal programming, like requires logon and exit if not needed, or something like this. That would be an actual method name for this, or an actual function name. And it's just to basically use the name to document what's happening in that chunk. Now, the nice thing is, when you do this, when you take some big area of code and you extract pieces and pieces and pieces and pieces, you end up being in this place where you start to see the skeleton. It's like if you take a body of an animal and you take off of the flesh, you see the skeleton. You start to understand the underlying structure behind things. And then you start to get ideas about where you want the code to go, what kind of things you want it to go and move towards structurally over time. Now, the tough part with this is that you gain all of this insight, and actually to do those refactorings as real refactorings often takes a lot of time. You're going to have to go back and get tests in place and do lots of work to do that kind of refactoring for real. But gaining the insight is pretty valuable. It took me a long time to realize that there's a reason why people don't do this, right? Has anybody ever done this before? Here? A couple people? Yeah. In general, there's two reasons why people don't do this. One is they're scared of somebody going and saying, why are you wasting time, right? And because we have this feeling that we should be optimizing our time towards writing code and getting things done. The other reason really, is that we never really think about modifying our code without the idea that it's going into production that way, okay? And that's just something because we're used to doing things that way. We never think about modifying things just to understand and undoing the modifications. We're never checking them in. And that's actually a very valuable thing. If we can do that, if we can just do things piece by piece in order to understand things, we're in a better state than we were previously. So I encourage you to do this, scratch refactoring. It's a great exercise to do. Maybe you take 2 hours in a conference room with a couple of coworkers to go and try to understand a difficult area of code. There's another practice too to discuss, and this is really about gaining the practice and discipline and awareness of refactoring within a team. And it's interesting because we can say, yes, refactoring is important, it's important, but we always seem to have something more important to do. What suggestive refactoring is when you start to notice some small refactoring that you can do, and instead of doing it, what you do is you put it into the backlog as a small piece of work. And sometimes these refactorings are not very big refactorings. They're very small things that would take no more than a half an hour. And you might say, well, gee, you might as well just do it if you can see it that way. But putting them in the backlog raises awareness. And then you have that thing where maybe I get done working on something maybe in half an hour before lunch. And one half an hour before lunch, I'm looking for something to do. I go to the backlog, I pick up that refactoring, and I do it. This is not something you need to do all the time. It's just a temporary thing in a team to do, to go and get people to go and see, you know, yes, there's always cleanup I can do. Let me see what's available. I'll do this particular thing. And again, it raises the awareness of refactoring in the team. Another one like this is something I call split preparatory refactorings. Okay, this is an interesting one in the sense that often when we're dealing with development today, we try to do everything we can to minimize handoffs. Like one group of people does work that they hand to another group of people, because we know that we lose information when we do this, right? This practice is about introducing a handoff in development in order to go and raise some awareness and get people used to seeing things in a different way. So what this is about, it's kind of like when we looked at the technical debt definition I gave a little while ago, is noticing that there's some feature we need to go and add into the code base, and it requires some refactoring in order to go and make it easy to add it in non-invasively, right? And what you do is you get two different groups of people to do those two different pieces of work. One group of people does the refactoring, and the other group of people is going to add the feature. And most of the time adding the feature is very, very small amount of work. It's only a half an hour or an hour to go and add the feature in. But the fact that the two different groups of people are doing those two different pieces of work forces communication back and forth between them. You start to go and have that conversation about how you are going to go and what work would it take to make it easy to add this feature in. And you do that work, that refactoring, and then you add the feature in afterwards. It's very funny about this because most of the refactoring that we are used to doing is refactoring after we have a mess, right? And I guess it's true that this is still refactoring after we have a mess, but this is refactoring before we add the feature, right? And that question is so vital, the question of what can we do to basically make it easy to add in this feature? Because then you really start to think about the design and you start to think about what it could be in order to make feature addition easier. So again, this is like the previous one. I wouldn't do this all the time. I would do this just to go and raise awareness of this practice of doing preparatory refactoring before doing the work in a team. Okay, next one is essentially what I call privileged abstractions. The idea behind this is that in many code bases you can have thousands and thousands of classes and functions, and it's hard sometimes for people to go and understand exactly what the most important ones happen to be. So taking some time within the team to go and sort of figure out what those major abstractions happen to be in the code base can be very valuable. And I don't know, I once heard someone say a long time ago that if you have an architecture you can't explain using 5 objects, then you don't have an architecture, right? It's kind of like there should be some primary abstractions in your code base, and if there aren't, you have some work to do. You have something which is not very easily understandable. So the idea behind this is to find those things, to find those key abstractions in the code base, and when you find them, document them, make sure everybody understands the system in terms of those abstractions. And yeah, you can document them in the code or externally, just making sure that you have conversation around these things, because that quite often guides you as you're making changes going forward in the code. Okay, another one too is this. Anyone ever hear of this term work in progress for like lean? Okay, there's the idea of like, within lean software development, this idea has been around for a while, that we shouldn't take too many stories at once or too many features at once in a code base. And things can actually go better if you reduce the number of things that you're working on as a team. And when people carry this to the extreme, they'll have like maybe only 1 or 2 stories going on at once, and then you guarantee completion very quickly. The alternative is when you're working on maybe 7 stories at once and you make progress 15%, 15%, 15%, and it gets distracting because so many things are happening at once. The idea behind this is to apply that same discipline to refactorings that happen in your code base. And I'm not talking about the small refactorings. I'm talking about the big ones, the things like introducing a new abstraction layer in the code that doesn't have it, isolating yourself from database APIs, things along these lines. Things like this may take many weeks to do, and they take concerted amount of effort to do these things. So if you have many things that you can imagine doing in the code base to make things better, pick one. Pick one or two, and make sure that you bring those to completion before tackling the next one. One of the worst things that happens in many teams is that once they start to realize that there are things they can do to make their architecture better, to refactor to make things nicer, they establish a giant list of all these things. And that giant list is okay, but you can't do all of them at once, right? You have to pick. And actually forcing that prioritization is a very valuable thing in much the same way as it's valuable for stories in a code base. This one I like a lot, architectural mapping, because it's fun. What this is basically getting a group of people together and drawing a picture of your architecture. But the picture is not just boxes and lines. It's imaginary. It's like, imagine you're inside a Plarium game, right? And you have landscapes and all sorts of interesting things you have to deal with. You can use your imagination that way with your architecture. And I don't know, I was working with a team a while back, and they had felt that there's like one controlling instance in their system, and it had coupling to a bunch of other ones. They drew a giant spider, right? So their spider has like a web, and then things get caught in the web, and there's also an octopus that things get tentacles into. And it's kind of a bit of a fantasy, role-playing type thing in a way. But drawing a picture of this helps you have a common vision as a team of what the structure happens to be. This picture that you have is a picture that is not just saying this is a bad area of code, it's depicting the badness. And you can basically redo this over time to see whether you've made improvements. Having a common vision of what is good and what is bad in the system. And that forces, again, conversation on how you will make changes as you go forward and do things. This one, silent alarms, is very powerful. I don't know how often this happens in different code bases that you're working in, but sometimes you can do a lot of checking to go and basically make sure that your code has certain design characteristics, certain style characteristics, all these different things. And they can actually be a little bit distracting in development. But what you can do is set things up so that basically some of these things don't really fail the build, but instead they notify you, or they notify one person on the team that some particular stylistic check hasn't passed, for instance. And with this, then basically you have an interesting thing that you can do within the team. I think that in general, when we have a good software development team, it's easy for us to transmit knowledge and understand the right way to make changes in a code base. But if somebody basically makes a mistake on the style of something, for instance, to go and get somebody on the team to receive that is pretty powerful, because then they get to be like a detective. They can start to think about, why did this particular thing happen? Why didn't this person understand that this was an improper way to make changes in the code base, right? So with that detective work, you start to see gaps in communication across the team. So the intention with this is to make sure that we don't have such strictness in our checks that we force a lot of rework immediately, but rather take the things which are minor and receive back channel communication about them so we can deal with them a little bit later. And so this can help with some of that kind of code change. This one right here, I'm not going to go into it in too much detail, but it's something that is very valuable. When you're trying to go and get tests in place around existing code, one of the things that makes things very problematic is a global mutable state. Say you're saving data off to a store, things along these lines. When you have that kind of mechanism in code, quite often you have to do a lot of work in order to go and make sure that you can separate the dependencies that keep that kind of code in place. So what this practice is about is setting things up so that you put in these abstraction layers so they are not kind of holding your particular code in place. I don't know how many of you have had this experience, but sometimes trying to take one piece of code and put it under test is difficult because you discover it depends upon this and this and this and this, and then you need all this data to instantiate these things to be able to go and do the work, right? So this is a matter of breaking the dependencies well enough that you don't have to go and sort of pass in a lot of external data to test one particular area of code. So it's essentially breaking dependencies. Another practice as well is direction tagging. And this goes and gets back to something else. How do we feel about comments? Are comments in code good? Yeah, they can be generally good, right? The thing we always worry about with comments is that they can go stale, which means that essentially, you have a comment and you have the code and you look at the comment and it's describing what the code was 3 months ago, and then it's confusing for everybody. So we have like an emphasis on trying to write code that doesn't require much in the way of comments because it's self-documenting. But sometimes we can add comments that won't go stale in that way. And that's what direction tagging is. It's essentially going and discovering the areas in your code base where you need to have work done, particularly refactoring, and actually adding a comment or a tag to that area of code that you can search for. Okay? And this is particularly useful when you have a large refactoring that involves making a similar change across many different areas of code. In cases like that, what you do is you just sort of mark it and say, this is refactoring, you give it a name, and you just mark it with a comment. And you do this in all the areas where you're going to do this. And maybe you start out with like 15 comments of the different areas for this refactoring. And after a week or so, that's down to 13. After another week, it's down to 7. And then finally, after removing the last comment and getting the refactoring done, you're done with that completely. So it's interesting with this. You could keep track of that externally, like in a file or something like that, but actually putting a comment in the code is okay. And we tend not to think about doing this sort of thing. But these are actually okay because they don't go stale as easily as other comments do. They just act as markers to allow you to search and figure out where you are in the state of a particular refactoring. So the last one I'm going to talk about before we take a break is something called transparent design quality. So in this talk so far, we've gone through a lot of things, right? A lot of things about team practice, and at the beginning, I talked about what I see that gets in the way process-wise with us tackling refactoring issues and technical debt and things along these lines. And I think that for the most part, one of the reasons why this happens is that we don't have a good base of communication between development and the people who are telling us what needs to be done, right? The people who basically decide what the features are going to be. In some organizations now, that happens as a very integrated decision-making process, okay? But in many cases, it's still not quite there. The thing which makes this very tough is that if you want to have a conversation with somebody in business, they're quite often in this situation where they don't quite understand the technology. And all they can do is trust you when you say, this is probably not the right time for this feature. Well, how many times does that happen? Do you ever go back to business and say, we can't do this right now, or we shouldn't do this right now? Yeah, we're supposed to be, one of the things that we try to do with all these agile software development practices is to set it up so you never have to say no, right, to business. Now the thing is though, you can usually work forward. You can usually work in a way where you don't have to ever say no, but it's not always a good idea. Sometimes you have an area of code which is difficult to deal with. And because it is so difficult to deal with, you say, look, we are better off doing another feature and coming back to this in a month. Can we do that? And then people look at you like, what are you talking about? So one thing I've experimented with in some organizations is the idea of building up representations of code quality that are understandable for people who are non-technical. And the idea is to avoid using numbers at all, right? Because quite often if you say my code quality is 45 and it should be down at 30, somebody will say to you, okay, reduce it by 5 in the next 2 weeks. So let's keep working on this. But these things are far more qualitative than quantitative. So as an example, here's a picture of a class in Java, okay? The rectangles are fields and the ellipses are methods, okay? The dark things happen to be private and the things that are transparent happen to be public. Is this a good class? Nobody wants to say yes because we're engineers, right? We're waiting for the trick, right? But knowing nothing about technology or knowing nothing about this class, we can say, yeah, it's okay. Do we at least know that it's better than this? That's a class also, right? Which one would you rather work in? The first one, right? So there are structural things, there are dependency things which affect the ease with which we can change things. And having representations like this when you're going and discussing things with people that are non-technical is valuable. The situation you'll find yourself in is that sometimes you'll show pictures like this, and then the people who are there in the organization will say, why did you let it get that way, right? And that's the hard thing. But I think that the answer to this more than anything else is constant communication. And so another thing I advise as well is whenever you have, like, say, a retrospective or a review, make sure it's not just about the features, okay? Make sure that it's also about the quality of the code and its readiness for change. You can establish like a readiness scale of maybe 1 to 5 and say, in our system we have 5 major components, the readiness is at these levels, and when somebody asks for a feature, you can say, yes, we can do it, and they say, oh, well, maybe this is taking longer than I thought it would be, and you say, yes, well, that's because this component has a readiness of 3 out of 5, because we did these other features and we had to get them out quickly. You remember we had that conversation, right? So this kind of thing is very important because it gets everybody in the organization able to understand that the things that you do have impact on the code. And we definitely know this is true, right? The things that we do have impact on the code. But what's tough is that's never part of the conversation. And then we are not able to make the healthy choices in development that keep us from accumulating too much technical debt. And then we have code that we're scared to refactor. And that's a rough situation to be in, right? So that's the end of part 1, okay? So let's take a 15-minute break, I think. And 30, okay. Take a 30-minute break. We'll come back and we'll go and dig into part 2. Part 2, we're going to actually start doing some code, okay? Thanks.
Are you ready? Yeah? Make some noise for Michael. Woo! Yeah. Mm-hmm.
Okay, we're back. Okay, so I was thinking about things to do for the second half of this, and I had a bunch of slides I was going to go and present, but I thought, no, it'd be better to go and actually work through an example, right? Refactoring is one of those things, you can read it in books, you can basically have people talk about it, all these other things. But there's a lot of decision making that goes on in the process of refactoring. And particularly some very small things. There's little habits about refactoring that you don't really see unless they're demonstrated to you. So, as I mentioned earlier, it's a set of small steps that it takes to go and actually, change the structure of code without changing its behavior. And in the original book, there's about 70 plus refactorings in it, right? But some of these things are actually very large compared to some of the things I'm going to show you now. What I really want to do is just kind of walk through a bit of an example and then go and give you some ideas about things that you might do to go and sort of help you check your work as you go and perform major changes within the structure of what you're doing. So how many people here have ever done test-driven development? Have you ever done test-driven development? Wow, only a couple of people. How are you guys getting your tests if you're not doing test-driven development? Do you have tests? Okay. Yeah, so having tests is one of the most basic preconditions you should have for refactoring. It does help that many IDEs today have built-in refactorings for you, and many of them will do the analysis to make sure that when you perform that refactoring, it doesn't impact the behavior of the system. But having tests makes things a lot easier. When you have tests, you can do lots of small little refactorings and get immediate feedback that they really are correct without having to worry as much. And this is one thing that I kind of learned early on in development, back in the very early days of this. I used to work at a biomedical company, and I would have this strange experience, like usually halfway into the afternoon, some friends would come by and ask me if I wanted to have Cuban coffee. I live in Miami, Florida, and they have coffee that comes in very small cups that's very powerful, and I would love to go and walk off with my friends and have coffee. But some days I would say, no, I can't because I'm working on this, and if I walk away from it, I'll forget what I'm doing, right? I kind of know that this is kind of working and not working. But after going and getting tests in place around my code, I discovered that I could easily walk off and get plenty of coffee, right? And walk back in and know immediately through the test execution what was working and what wasn't working. So this background of test execution allows you to do a lot of refactoring. And the thing I'm going to show you now is that you can do quite often a lot of refactoring that almost seems like just writing code, but it really is refactoring. So I want to walk you through a couple of things here. First off, for those of you who have not really read much about test-driven development, this is essentially what the cycle is. What you're supposed to do is write a failing test case that goes and depicts some behavior that you want to go and have in your code. And it's going to fail because that behavior is not there yet. So then you write the code it takes to make that pass, and then you have green for your test passing. And then you can do whatever refactoring you want to do, and then you go and you do this again and again. Now, the thing that people don't realize much is that, as I said, you can do a lot of refactoring in that space. So let's talk about that a bit. Okay, I'm going to jump over here, and this is just some very simple toy Java code. It's not anything terribly realistic, but it's there enough to go and give us some background. So this is kind of like the beginnings of like a sales system for, say, a store or a restaurant or something. You have something where you're able to go and add barcodes to the sale, like a SKU for like a point of sale system. And then what happens is the sale is supposed to take that information and record it and also put up on the display what it is that you've actually just scanned. So if you look at the code here, we can see we have a sale class, right? And that sale class accepts a display. And the display is really just an interface that has one method on it called showLine. So you pass a string to it, and it goes and shows the line on some display device. So going back here, we can see that we have a fake display, and this is something we're using instead of a mocking framework, just to keep things simple. What this does is it accepts a line. You basically tell it to go and show a line. What it does is it saves that line so you can check it afterwards in the test. So here's our test. We create a fake display. We create a sale that's linked up to the fake display. And what we then do, let me go and get rid of this here, is we go ahead and add a barcode. And then we can perform our assertion. What we do is after adding a barcode, we check to see that the display, the last line seen to the display actually has this format. So somebody just bought milk and it's $3.99 in US currency. So we have that, and we can look at the code behind this, and you can see that it's terribly ridiculous little code here, right? Essentially we have, if the barcode is equal to 1, we just go ahead and we display this. Is this a complete implementation? No, it's absolutely ridiculous. Couldn't we generalize this a bit? Yeah, we definitely should, right? Because now it's just going and matching a single string barcode to a display string. But let's go ahead and sort of continue to go and make this move along in the same direction that we have here. So that test is show line for added item. I'm going to create another test here. I'm going to go and say show line for another added item. And this time I'm going to pass in 2. And this is going to be something else. Cereal, and we make this $2.99. Okay, so is that test going to pass or fail? It's going to fail, of course, right? So let's go ahead and see the failure. We can see that. We can march along and see what's going on here. So the simplest way of going and making this change is to duplicate this. And I'm going to go and say if we have this, then we make this cereal. And we make this $2.99. And once we have that, it passes again. Okay. So we still haven't generalized anything at all here, right? Should we refactor? Yeah. So what can we refactor to? Well, one thing that kind of helps is to go and basically have a very strong sense of what code smells are. And in the original refactoring book, Martin Fowler listed, I think, about 20 plus code smells, things that you look at and you say, this is a bad thing. But some of these are actually more subtle than you might think. So what duplication do we have in this code right here? Yeah, well, we have the equals for these things. We have 2 if conditions. That's very obvious. But there's a piece of duplication that's here that a lot of people don't really think about or see. There's duplication between this and this. Yeah, so what's the duplication? It's really duplication of format in a way. In both cases, we have a product name, a space, and then a price, right? So can we solve this problem? What we can do is we can introduce a new class to do this. So I'm going to go and say I want a new class. I'm going to call it item, for instance, right? And what's it going to need to actually basically do the work here? We have to have some way of going creating them. So I'll have a constructor, pass in the name, pass in the price, and the simplest thing we can do now is make the prices into strings. Whoops. I've always had difficulty talking and coding at the same time. So we have that constructor. We're going to want to basically see, we'll call this get display string. And this is not the best implementation, but what I'm doing here is I'm searching for some behavior that exists in the program already. And when I have that behavior, then I'm able to go and write something that goes and produces it in a nicer way. So I'll say we'll do this, name plus price. And if I'm going to do that, that means I'm going to have this.name is equal to name, this.price is equal to price. Sorry. And I need to go and have variables for both of these things. So we'll have private, a string, name, private, string, price, right? Okay, so we have that, and we have a class. Now, it's funny about this. I didn't write any new tests, and I just wrote a class. Is this an abuse of the process? Seems like if you're doing test-driven development, you should be writing tests to trigger the creation of new classes, right? But an interesting thing is that in the early literature about refactoring, one of the first refactorings that was actually listed was one called add class. Is adding a class to a system a refactoring? See, most of the times when we add classes, it's to add new behavior, but technically, this class that we have here is not adding any new behavior. This thing right here is behavior that exists in the system already, okay? And you'll see as we start to use it. And you can even go to a more basic level than that. Adding this class to the system definitely doesn't change any behavior because we're not calling it, right? So just adding a class is a refactoring. Actually, using the class may not be a refactoring. If you use the class and it introduces new behavior, that's different from refactoring, right? So now that we have this, what we can do is we can leverage the tests that we have there already in order to do something interesting. I'm going to try to do the smallest thing I can do in order to go and exercise the functionality that I just produced and use the same tests that I have to do this. So I'm going to say new item, and I'm going to pass in this, and now I'm going to say get display string. Okay? So this is very simple, very ridiculous, but it does work, right? So now I started to substitute in this particular class duplicating behavior that existed already, right? Now, one of the things that I think is really a very powerful practice when you're refactoring is looking for the simplest thing you can do to exercise the new code that you're replacing something with, if you're doing that, something like that. So, you know, one way we could have done this, I could have done this new item thing in both places immediately and seen, you know, and if there was a problem, I'd have to undo both places. So why not just do one place, see that it's working, and now we have the confidence it takes to go and actually do the next piece, right? So we have that. We can actually now carry this further and do this here, like this. And see that this is actually still doing the same thing. Right? Now, having done that, do we still have duplication? Yeah, we still have duplication. Okay, so how do we go and actually deal with that duplication? Well, one thing we could do is we could create like a hash map or something of items and do a lookup in order to go and find them. So I'll introduce something like that. I'll say private hash map of string to item, and we'll call it items. Add this. Okay, and is that a refactoring? Yeah, because we didn't change anything, right? We've added new variables, so we can run our tests as many times as we want to and see that nothing has actually changed with that. So now, simple thing to go and do with this. We can start doing the work of saying, okay, we have items, and we're going to go and add new item like this. Okay. Items. It's been a while since I worked in Java. What is the? Yeah, just put. Okay. Oh, so I need the key. Okay. So we have this. And now that we have that, again, this is still refactoring because we aren't changing behavior at all. But now we can go ahead and replace that here and basically go ahead and say that we'll go and say items, get barcode, and see if that still works. Yeah, it does. Okay, so now we can go ahead and do this piece here. Okay, so this becomes 2. This becomes serial. So when you're working this way, you develop like a rhythm. It's just like one simple thing after another. And now that we have that, we can basically do this here and see that it's going to do exactly the same thing. Okay. So what do we need to really be able to work this way? Well, we need tests that run very, very fast, right? Because then you don't have to pause or wait or whatever. You make the change, run the test, make the change, run the test. And if you're working in an existing system, sometimes your tests take forever to do. But the nice thing about going and working this way with the tests is that you often are able to decouple things in such a way that you can still have just a small set of tests working in your local area where you're doing your code, as opposed to running all of them when you're trying to go and get this level of feedback. Okay, so we have that, and now we can actually go ahead and try to make this a bit simpler. So we can now get rid of this entirely. Now it's funny, I did this and it's like the code made no sense, but it still ran. I think it's an interesting thing to discuss with this, right? Would you ever want to leave your code this way? It looks ridiculous, right? We're actually going in sort of having these if conditions that don't matter at all. But the thing is, the code still runs at this state. This is valid code. It's all these spaces where you have code that has the same behavior, but it looks kind of funky like this. Those are all options you have in deciding where you're going to go next. So I'm going to get rid of these things entirely. And we have this. Okay, and we're still leveraging just those two tests. But we have more structure like this. Okay, so we have that. Now, it's very funny about this. We go ahead and we make a call to items to go and get these things. This is really more like an inventory in a way, right? Some place where we hold on to products or something like that. Does that stuff belong in this class, the sale class? Probably not, right? It's not a great place for this. So what we can do is we can introduce a new class, right? So I'm going to, let's see, I guess I can go back and I can write a test for an inventory class, right? Do I need to? See, there's different schools of doing this kind of work in test-driven development. One says that as you discover the need for another class, you mock it out and pretend that it's there, and then you go over there and you create the class at another point in time. That's one way of going. Another way of doing this is to go and actually take the behavior which already exists and factor it outward. So let's go and do things that way. What I'm going to do now is I'm going to introduce a new class. I'm going to call it inventory. Whoops. And I'm going to now move over here. We have our, we have this hash map. I'm going to take this and I'm going to move it over to inventory. And I'm going to make it public. Now I could have used the refactoring tools that are built into this, but you know, you may be working in tools that, in languages that don't have that. I moved that over, so now let me get rid of this. And you'll see that we have all these checks saying that we can't find this thing anymore. What if I now go ahead and create an inventory? And as I do this, I can say that I will have is equal to new inventory, like that. And now I can say I want this thing in front because I made it public. And now I can do this. This is probably not the way you want your code to end up, right? But it was a very simple step to go and actually start to introduce that class. Now that we have that class, what can we do? We can clean things up a bit, okay? What we can do is we can take this stuff that we have over here and move it into the inventory and its constructor. So we'll say public inventory and drop these things down here. And get rid of this. And of course, this is not going to be the final resting place of these things. They're going to go in other places as well. But we're able to do this in a very smooth manner. Now, once I have that, what I can do is perform an extraction. Let me actually go ahead and run this first. Okay, it still runs. This right here, we're going and accessing the items, right? But that's kind of ridiculous. We'd actually like to have a real API function for this. So what I'm going to do is I'm going to go and extract a method for this. And here I'll just go ahead and use the refactoring tool that's available. So refactor, extract method. Is it going to let me? It is. Okay. I'm going to call it item for barcode. Okay, so we have a method called item for barcode. And now we can go and actually take that and move it. And move it over onto inventory. And it's going to change the visibility. And so it's always, yeah, I hate when this tool goes and gives you a this pointer there for mysterious reasons. Let's go back to this. We don't need to pass a sale along. And we have that. Okay, so we have that done there. So notice where we are, right? We were able to go and introduce a new class, and we really didn't introduce any more tests. We just have these two simple tests here that are covering the behavior, and we're just going and doing all this refactoring to go and build up the structure the way we expected or want it to be. And we just basically take all these small steps in order to go and do this. Does the code look decent the way it is? Does it look kind of like code you'd be proud of? Or are there any problems with it? Well, we're not dealing with any error cases at all, are we? Right? Sorry? Yeah, dependency injection for what? Inventory? Yeah, we can do something like that too. But I'm really more concerned with this thing right now, that essentially if we pass in something that isn't seen, we're in a bit of trouble. So let's write a test for that. And notice that now this will be new behavior, because we're looking at the code and we kind of see that we're in a situation where this code is extremely clean, but it has no error checking at all in order to go and deal with the things that we care about. So writing a test for this, we go back, and we have to go and say we want test, public, void, and I'm putting an X here because I'm still thinking about what this test is going to be. I want to put in something that doesn't exist. So let's say barcode 0 doesn't exist for us. And we can say invalid barcode. So what should happen if we execute this? Well, I guess we can find out, right? Yay, red bar. Okay. So we get a null pointer exception. Is that what we want? Probably not, right? We want to go and have some real behavior there. So what's the right answer? What do we do now? Well, whenever anybody asks you what the right answer is, you have to say it depends, right? Because it really depends upon the context. What we have to do now is decide what we really want to go and have in terms of behavior, and then decide how to go and get it in place. So one thing we could say is that we want to go and test for an exception, for instance. If that's the case, then we would go and do code in one way. Let's go ahead and do something a little bit strange here. In this case here, I'm going to go and carry back my idea and think about, instead of thinking about errors, I'm going to think about what behavior I really want. So what behavior would I really want if I do an invalid barcode? Well, one thing I could say is item not found. What's the price of an item that's not found? Yeah, it should be 0, right? I'm not saying this is the best way to do this, but it really helps. It's really an interesting thing to consider, that when you're approaching the design of something like this, you have to think about what is your ultimate feature, what is the thing that you really want, and then sometimes things occur to you. So if I run this, again, it's going to go and naturally tell us that there's a problem, right? We still have a null pointer exception. So how can we fix this? Well, what we can do is we can do something like this. Let's see, we have our get, and it's going to be returning things this way. What we can do instead is we can say item is equal to items get, and we pass in barcode here. Okay, and then we can say, whoops, this here. Okay, we can say if item is equal to null, return new item, and our item will be item not found, and the price will be 0, whoops, 0, 0, like this. Otherwise, we would do that. Let's see if that works. And it does. And our code stays very clean here in the sense that we don't have to go and deal with any kind of an error check. Is this a good idea or a bad idea? It depends, right? It really depends. Anybody know what this pattern is called? There's a pattern for this. It's called the null object pattern. And it basically comes from the case of saying, instead of going in and doing things like returning nulls or option types or whatever, what we do is we basically go ahead and create an object which represents the absence of something, right? And that can work in cases where the callers don't have to care about the fact that this is not a real object. And in this case, it's a little bit iffy with this because we know that we have an item here that has a name and a price. The thing that we're passing back is a message like item not found. That's not really the name of a product, right? So it seems like we're kind of abusing things a little bit when we do this. It's not the best thing. And it's very convenient for us that the price of 0 will add up with all the other prices and produce something nice for us if we total up the sales for these things. But again, that's one of those things where it depends upon the particular problem. So is this the best way to do this? Probably not. But is it an option? Yeah, it's an option to go and do these sorts of things. So you can slowly go ahead and start to build up something like that in response to the particular tests that we're executing. Now, if I was going to give this a name now, I would say shows item not found. Whoops. For item not in inventory. I don't mind test names being long like this at all. And quite often when I'm working, I will go back and change the names periodically as I start to develop better knowledge of the domain and a better way to express what it is that I'm actually trying to communicate with this. So that's a decent name for this. Could we have done this a different way? Yeah, definitely. So one thing we can do with this as well is we can say, look, let's go and back up a bit here. Okay, take that test out and choose to go towards using an exception. So in this case here, what we would have to do is basically say that we want to have a new test, has this, and let's see, in this case, let's say throws not found for unfound item, for item not in inventory. Okay, so if we're doing that, then let's see. Let's see, recalling that expected. Forgot what that. Does anybody recall what that is for Java? Say it again? Yeah, okay. Exception equals. Okay, I'm just going to do it the simple way. Okay, so if we do this, and this is actually the way people used to do it before having that. Okay, we do this. And if that's the case here, and I guess we'll say item not found. And essentially, thing goes like this. So if we catch item not found, everything is fine. Get back to this. Is that right? Okay, so we need to go back to where it is with the sale. And we now have to, I guess instead of using a checked exception, we'll make this a runtime exception. Where is this? Inventory. Okay, so if this just put the fail here. Okay. Expected item not found exception. Okay, so let's see. And that's not being thrown, so we can go back to this and make sure that that happens. And do this. So that becomes item. This. And essentially we can say if actually no, I'm sorry, that's back in the inventory. Okay, so in this case here, okay, so we have that, very simple that way. Okay, so we've gone and built this up with a small number of tests. We've been able to go and introduce a lot of structure going and leveraging the tests as we go forward with this. So yeah, any questions at all about this? About how we've approached this? I think one of the things which is really fascinating about doing this kind of thing is that it's often very beneficial to go and introduce duplication as you're refactoring. So you introduce the duplication. Quite often you have this point at which you're just choosing to go and enable the new functionality that you've added, the new structure, and then you just sort of take the old structure and peel it away as you've gone and replaced the old structure with a new structure. And the thing about this, which is rough in a way, is that as you do this, you have to go and ask yourself this question: should I have tests for this particular class? Is it worth having tests for this particular class? Yeah, it's kind of funny, isn't it? So sometimes I'll go back and I'll add them, and sometimes I won't. It really depends upon whether I see a good need for documentation of what this particular piece is doing. At the very least, though, I have a rule that I use when I work, which is that if I now am going to be a new client of this class, first thing I do is I look and see if there are any tests for it. If there aren't any tests for it, I write those tests in order to go and have some confidence in how it works prior to going and using it. But right now, everything that we have here, all the functionality that we have in this particular thing, happens to be covered by these couple of tests that we have here. And that's kind of nice, you know, since they're right there, it's easy for us to go and deal with. So. Okay. as we go back to this. Does anybody feel weird about the fact that there are no checks here with this? It seems like it's kind of interesting. We just go to the item for barcode and we just assume that it's going to return it back to us. We dereference it immediately. Sometimes people get a little bit upset when they see this code. They want to go and check for null, right? Should we check for null here? Yeah, it's an interesting thing. We're slowly getting to the point within the industry where we shouldn't have to worry about null very much, right? Since we have option types and various other error handling mechanisms. But in many code bases, what I notice is that people have all sorts of crazy null checks all over the place. And the reason why is because somebody looks at a piece of code like this and they think, oh no, we have a danger. We have some kind of a problem here. If this thing returns to null, we're going to get a null pointer exception when we do this. But we can tell, looking at the code, that this is actually covered by the case that we happen to have over here within inventory. It's actually nice to get to the point in your code where you don't have to check for null at all. And you don't have to check for null at all when you get to the point where you choose never to return null back to somebody, right? So in this case, we know that the only error condition we can have is going to be something that goes and throws an exception. If you don't get an exception, you're going to go and get back an item. And being in that situation, you're pretty good, and you don't have to go and have as many null checks. But the thing that's funny about this is that because of our insecurity, we often go ahead and propagate more and more null checks in the code. And it's also an unfortunate thing that trying to go and put this discipline into a code base after the discipline has gone away is very difficult to do. Because once you have a huge code base and lots of null checks, as soon as you start to write code like this, people get very upset because they're like, why isn't there a null check there? Because we need null checks because we keep getting null pointer exceptions. But the important thing is to basically try not to return null from code at all. And if you're in that situation, you can find that your code becomes much cleaner as you deal with things. So yeah, this is a general issue of error detection and recovery in these places. So yeah, they wanted to kind of do this and kind of walk you through, smaller steps as you're doing your work. Was this a surprise to anybody? Doing things in this small step? I'm going to ask again, how many people do test-driven development? Okay, more hands this time. Ha, okay. You're just shy before, you didn't want to talk about it. But really, there is no other way, easily to go and get tests in place as you're doing your code. I find that for a lot of the code that I'm writing now, I'm using a more functional style, and writing tests first is not quite as easy as writing them afterwards, but I often find myself in this state where I'm not sure if I have all the cases. But if you're working in OO code like this, quite often writing the test as you write the code goes and helps you a lot. It gives you the coverage that you need to be able to go and do these things. And in particular, as I was pointing out, these really small steps, okay, just to be able to go and have this question, does this thing work this way or not? Run your test and find out. And it's great when you can run your tests every 5 seconds, for a particular area of code you're working in. And once you really get used to going and doing that sort of thing, you start to go and notice that when you're working, it's almost like a game in a way. You try to think of what's the next thing I can do, what's the smallest change I can make that's going to allow me to go and run my tests again. And all those little things are micro refactorings. They're very small refactorings that don't seem like they make things more maintainable, but they are stepping places between where you are and where you want to be. And just being able to go and see those options is pretty powerful as you go through and you do your thing. So yeah, that's, I guess, as far as I wanted to go with this. I guess what we can probably do is open this up for questions. Is that good? Okay. So, anybody have any questions at all?
Yeah, guys.
Fast.
So, anybody, do you have any questions? Don't be so shy, please. No?
Wow.
It's the first time. Yeah. Whoa. The microphone is here. Yeah.
Hi.
Hi.
I want to ask you, what if we have the project with big legacy code, and how we can try to start our refactoring? What we need to profile our code to find out how much functions calls, etc. What do you suggest?
Okay, if you have a big project and it's very scary code, what do you do, right? One of the things I really advocate is like if you have like Sonar Cube or something like this, and even if you don't, you can quite often very easily find churn statistics for your code base. This would involve just going and using, say, git log, for instance, looking at all the commits and basically finding out how many times a particular file has been changed, right? And if you sort all of the file changes that you have over a time period, you'll see which areas of code get more change and which ones get less change. And this is very important because often we see a giant code base and we think that, oh, we have 5 million lines of code, it's never going to be fixed, it's trouble, it'll always be trouble. But often in code bases, we don't have to worry about all the code. We need to pay more attention to the areas of code that get changed more often. So once you understand which areas of code are getting more change, what you should do is go and look at those areas of code and try to figure out what direction do you want those areas of code to move in. So a good example of this is sometimes you'll find a file that has many, many changes and you discover that you have a giant class or something which has 50 methods on it or something like that. And then as you see that, you realize that maybe there are many responsibilities there. And you develop a plan with your team that over time you'll split these responsibilities into, say, separate classes, for instance. Doing this with the areas that have high change helps you establish what direction you want your code to move in over time in the organization. But the important thing to recognize is that you can't just fix it immediately. And any code base that you have has grown in a particular state. You have to basically pay attention to the important areas, the ones which are demonstrated to have more change, and figure out what to do in those areas.
Okay, thank you.
Okay, yeah.
Hello,
Hi.
my name is Klim. So what I didn't really understand is that why do we need to create tests on the go, so test-driven development? Why can't we have some code, write tests on this code, so think right away of every test case, and only after that do some refactoring? Oh.
Yeah, it's when you go to the store, you can go to the store with a shopping list or not, right? You can think all day long about the things you might go to the store and do, and then there's the chance of forgetting those things, right? So you could write your code and make a list of all the things you want to test, and that's very good to make that list because otherwise you'll forget, right? When you're doing things test-driven, you are dealing with each problem as you encounter it, right? And the nice thing also is that it's often very natural to go and think of error conditions as you're going and adding behavior in, and as well there's an emphasis on not over-engineering something because you're writing only as much code as it takes to pass the test, which is the traditional argument for test-driven development that way. So yes, you can write the test afterwards, but it can be more difficult sometimes.
Maybe combined approach then?
Yeah, no, definitely. And actually, historically, the first name for test-driven development was test-first development. But Kent Beck thought better of that. He thought, let's call it test-driven development because sometimes, yes, you do write the test afterwards, and that's valid also. So,
Yeah, thanks.
sure.
Thank you. Now I have the way to influence our managers to make them give us time to refactoring. But my question is about the code bases with the code which is likely impossible to cover with unit tests, multi-threading, network. How to work with micro refactoring in such?
Just you throw that code away and write new code. No, just kidding. Yeah, you're right. And multi-threading is especially problematic with testing because I have this theory that if multi-threading was designed today, knowing what we do, whoever came up with the idea of multi-threading would be thrown out of the industry. It seems like such a silly idea to allow a scheduler to interrupt any process and anything to change any value, shared state, multi-threading. But if you have that kind of code already, yes, it's going to be difficult. The thing that's important, though, if you are writing tests for existing code, is to recognize that you only need to write the test for the thing you want to verify right then. And so you can write very, very specific tests for the things that you're about to do, and then tests for the things that are higher level consequences of those things. And that's often easier than trying to tackle a big thing and say, this works under all cases, right? So trying to basically test something very close to the point of change often gives you precision in the changes that you make.
So if I want to change something in multi-threading program, I have find what I want to change, then write tests, and then change it, yes?
Yeah, and then I think another thing with this too to recognize is that it's nice with multi-threaded code to have some separation between the area of code that's dealing with the threading and the area of code that's not dealing with the threading. One of the things I recommend in my legacy code book is that if it is at all possible with existing code, try to write new classes and methods and call them from inside the old code. So you can use test-driven development for a new piece of code and then call it from within that multi-threaded context. And you just have to be aware of what potential contention points are for this, right? And if you're lucky, maybe it's code that doesn't affect those points at all, and you could just treat it as code that isn't multi-threaded, but is called in a multi-threaded context. So.
Understand. Thanks.
Sure. Yeah.
Okay, guys? Yeah. Great.
Here's a little not technical question.
Okay.
How would you pitch, maybe you have advice, how would you pitch the need to get for the refactoring to the client? Because obviously it takes time, it takes money, but the benefits are not really obvious to them.
Yeah, and this has been the historical question people have always had. When Martin Fowler wrote his refactoring book, he had a chapter in there, and it was called "Don't Tell Your Manager," right? And it's an interesting perspective on this, because the attitude back then was really that refactoring is part of doing a good job, and if we always want to do a good job, we will take the time to do it. But we also recognize that there's pressure to get things done quicker. And there's another thing about this that people don't really recognize. Even when there's no pressure to do things fast, quite often developers will not choose to refactor because they're so used to doing things fast. They just basically do what it takes, and then we're done, we can move on to the next thing. So it's a matter of habit with this. I think that the bigger thing now is to make business aware of how quality goes up and down in your code over time. So you can have that conversation where they say, oh, well, this is taking more time than we thought. And you can say, yes, it's because the quality was down, and we told you last week the quality is down in this area of code. If you want us to go faster, we have to work in this particular way. We have to do this. And the thing about that is maybe they don't care, and then you're in trouble. But really, the health of a code base is important for your business. And if you allow the health to deteriorate, it's going to become obvious to the business at some point. And the question is, can we make them aware of it early enough? Because they must have that interest, that this should be healthy. If they don't, it's you're doomed, right? So, yeah. Sure.
Thanks.
Hello.
Hi.
I wanted to ask, even in this simple example, we have added a lot of abstractions. And how we should understand when we should stop, not to over-engineer.
Yeah. I think many of those things, they are a matter of judgment, right? And you just develop that judgment as you gain more experience. The important thing on a team is to have conversations about these things so that you have the same approach inside your team to doing things. And maybe you have arguments about these things, but that's okay. You all learn and go forward. In this here, I think every abstraction I introduced was either the result of duplication or an error, right? It's fun. Some of these are very funny because they seem like a stretch. When I say milk, $3.99, and cereal, $2.99, there's duplication there. That really is duplication. And if you start to notice that one way out of that duplication is to introduce an abstraction, then you can use that as a basis for abstraction. So, yeah, these things should all be relatively simple responses to code smells as you go forward, and that helps you avoid the over-engineering, I think.
Thank you.
Sure.
Okay, guys, any questions? Maybe anybody last question? No? Are you sure? You're gonna regret it. Yeah.
Hi.
Hey.
I have a small question. How do you think, what is more complicated, an actual process of refactoring or selling the need of this refactoring to non-technical people from management?
Oh, I think it's
Thank you.
definitely the latter, selling it to non-technical people. And it's so I have a website. It's I think I put up here, and I have some papers about this. If I go back to one of the things I'm trying to get more people aware of now is, oops, that yeah, on this website, I have some papers about something I call symbiotic design practice. And what the idea is basically getting organizations to understand how the health of software impacts them. And I think that this is really the next step that we need to take in the industry, is that we have for a long time thought that it's okay to abstract away the software from the organization, but I think now that that's a mistake. You'll probably notice this as you see different companies that you can work for, that some companies, maybe they have technical founders or they had very good early technical people there, and they have a culture around keeping the software good. And other companies are writing software and they don't even know they're writing software. Okay? My favorite examples for these are often like banks and insurance companies, that they have such an old domain. Banking has been around for centuries, and so has insurance, that most parts of the organization don't even realize they're writing software. They just put some people in a room and write software for them. So they don't really know what the impacts of poor decision making will be. And then you have companies like Google and Amazon and Facebook who pretty much started with either software developers or early people, and they can have that technical conversation up and down the entire organization and people understand. And I think that for companies that do a lot of software development that aren't aware of these issues, there are many traps. So it's good to raise the profile of that kind of thing. So yeah, I'd encourage you to go and basically take a look and see the essays there to understand more. So. Okay.
Okay, guys, I guess that's it. I wanted to say thank you, Michael.
Thank
it
you.
was a unique experience.
Thanks.
Give it up for the Michael.
Thank you.
Thank you guys for coming. Thanks everybody who watching live stream. We really appreciate it. I wanted to say thank you to the uDev team. You guys rock. Check our updates. Follow us. You can see a video of our tech talk on Plarium Facebook page or uDev website. So, see you soon, guys. Thank you. It was amazing. Have a great evening.